Dear students, today I'll discuss with you some important MCQ from the chapter solid state. The first question is, if A stands for the edge length of the cube system, simple cubic, BCC and FCC, then the ratio of the radius of the spheres in this system will be what, respectively what? You see, for simple cubic, question number 1, for simple cubic, your radius is a by 2. Okay, so for simple cubic, you see this is the simple cubic. Okay, simple cubic, this is the your A. And what is the radius? Suppose here one lattice point is there, here another lattice point is there. Okay, so its radius is this one, its radius is this one. Okay, so this radius is a by 2, radius is a by 2. Okay, then for BCC, body centered cubic, the ratio, see the ratio is the R, radius is root 3 by 4a. For BCC it is root 3 by 4a. You have to remember these things. Okay, for FCC, the radius is 1 by 2 root 2a. Then you calculate the ratio. Okay, you take the ratio, a by 2 is to root 3 by 4a is to 1 by 2 root 2a. So choice A is the correct answer. Next, so how these are calculated I will explain in another video. Okay, next, a metal has FCC lattice, the edge length of the unit cell is 404 pm. The density of the metal is 2.72 gram cm cube per cm cube. The molar mass of the metal is what? Okay, so for question number 2, you put the formula. You see, the density is Z. What is Z? Z is known as unit cell constant. Z is unit cell constant. Z is unit cell constant. What is the unit cell constant? That means number of particles present per unit cell. Number of particles present per unit cell. That is known as Z. Okay, so density is equal to Z multiplied molar mass divided the A cube, the edge length cube, multiplied Na, Avogadro's number, and it is you are taken 10 to the minus 30. Why it is? Because ppm is converted into the what? In the CGS system. So generally what is taken? 10 to the power minus 10 you have to take, and you have to cube this, so therefore directly 10 to the minus 30 is taken. Okay, then you put all these things. What is asked? Metal, the density of the number of the molar mass of the metal is asked. So for M, you have to take rho multiplied A cube multiplied Na multiplied 10 to the power minus 30 divided Z. Okay, so you put all these things. What is rho? Rho is given your, the density is given 2.72 multiplied A cube, the edge length 404. Okay, it's cube. Na 6.02 multiplied 10 to the power 23 multiplied 10 to the power minus 30 divided Z. So for it is what it is taken FCC. For FCC, Z is equal to 4. So if you solve this, you will get what is, you will get 27. You will get 27. Okay. So the answer is 27 gram mole inverse. Okay. Next question. Question number 3. The number of atoms in 100 grams of a FCC crystal with density this much and cell as equal to 200 pm is equal to what? Same formula. You have to put same formula. Okay. So take rho density Z multiplied m by AQ multiplied 10 to minus 30 multiplied NA. Okay, that is 6.023 10 to 23. So you put what is asked. Question number 3. What is the number of atoms present in the cell at z equal to what is equal to what? Okay, so m is asked. Okay, so what is m? You see m, when you calculate m, rho multiplied AQ multiplied 10 to minus 30 multiplied NA divided Z. So all these things given, your Z 10 to power 10, what is density 10 multiplied AQ, A is given what? 200 pm, 200 multiplied 10 to the minus 30 multiplied 6.022 into 10 to the 23. Okay, divided Z. For FCC it is what? 4. It is 4. So you will get the answer, you will get the value, it is 12. Then for it is asked, but it is asked for 100 grams, so you are getting 12 gram. So 12 gram is the molar mass. 12 gram contains how much number? 6.023 into multiplied 10 to the 23 atoms. Okay, therefore 1 gram contains 6.023 multiplied 10 to the 23 divided 12. Therefore for 100 gram you will get multiplied 100. So the answer is 5 multiplied 10 to the power 24. So the answer is choice A is the correct answer. Next, ice crystallizes in a hexagonal lattice having a volume of the unit cell as 132 multiplied 10 to the minus 24 cm cube. If density of the ice at the given temperature is 0.92 gram cm cube minus 3, then number of water molecules present per unit cell is what? So question number 4. You always put the formula. So what is the formula? Formula is rho is equal to Z multiplied m AQ multiplied Avogadro's number. Okay, so you are given Z is equal to rho multiplied AQ multiplied NA divided m. So you are getting water. For water it is 18 ice molecular mass, rho is given 0.92 and AQ is given 132 multiplied 10 to the minus 24 and your Avogadro's number 6.02 multiplied 10 to the 23. Okay, so by solving these you will get what? You will get 4.06. So approximately it is 4. Okay, so choice D is the correct answer. Okay, you see what is given here? The volume is given. That means AQ is given. Therefore I am putting 132 multiplied 10 to the minus 24. Directly I am putting this. Okay. Next question number 5. You see, lithium has a BCC structure. Its density is 530 kg meter cube minus, and its atomic mass. To see question number 5, what are the things given, and according to this you have to choose the formula. So for question number 5, what is the formula? Same formula you have to repeat. Okay, so 1A is given, the adds is given, what? The adds is given in PM, picometer. The other things are given in CGA system. Okay, other things are given in CGA system. So according to this formula is rho is equal to Z multiplied M divided AQ multiplied Avogadro's number and 10 to the minus 30. Why I am putting 10 to the minus 30? That means you have to take 10 to the minus 10 and multiply it and cube it. Okay, so then what is asked for BCC? You see, for BCC, body centered cubic, Z value is 2. Okay, and M is given 6.94 gram mole inverse. Okay, so putting this you will get what? AQ is equal to, how you will get? AQ is equal to Z multiplied M divided rho NA 10 to the power minus 30. Okay, so you put all these things. Z is 2, M is 6.94 divided rho value is given 530. Okay, Na 6.023 into 10 to the minus 23 divided multiplied 10 to the minus 30. So by putting all these things you will get the value AQ is equal, you will get AQ 43.5 multiplied 10 to the power 6. But our requirement is A, so you are getting A is this much, so A will get how? 43.5 power 1/3 and it is 10 to the power 6 2. Okay, so 43.5 1/3 you will get what? You will get 3.52 10 to the power 12. Okay, so approximately it is 3:52 PM. So the answer is 3:52. Choice D is the correct answer. Okay, next, iron exhibits BCC structure at room temperature above 900 degrees centigrade. It transforms to the FCC structure. Okay, the ratio of the density of iron at room temperature to that at 900 degrees centigrade, assuming molar mass and atomic radius of iron remains constant with respect to temperature. Okay, is what? So what is asked? The ratio of the density of the iron at room temperature to that at 900 degrees centigrade. It is asked. Okay, so question number 6, how to do? Same formula put, rho is equal to Z multiplied M. Okay, that is AQ and Avogadro's number. Same, and all these problems will using the same formula, but you have to solve how according the given values are given. Okay, so M and A remains constant. M and molar mass and adds length remains constant. Okay, so what to do? If these are constant, then you see the density is directly proportional to what? Z. Okay, rho is density is directly proportional to Z. So for FCC, you see, for rho the BCC body centered cubic, and rho for FCC must be equal to the ratio of ZBCC by ZFCC. Okay, so but ZBCC is equal to 2 and Z for FCC is equal to 4. So the ratio is 1:2. So choice D is the correct answer. Okay, next, an element X, atomic mass 40 grams per mole, having FCC structure, has unit cell adds length of 400 pm. Calculate the density of X. Okay, calculate the density of X, and the Avogadro's number is given. Same formula you have to put. You see question number 7. Same formula you put, and you will get the answer. A is given 400, and FCC ZD is equal to 4, and you put the formula, use the formula, rho is equal to Z multiplied M by AQ, Avogadro's number. Okay, you put the formula and you will get the density. It is 4.15 gram cm minus 3. So question number 7, 4.15. Choice A is the correct answer. Okay, next, copper crystallizes into FCC lattice. Its adds length is 3.62 and multiplied 10 to minus 8 cm. This is A is given. Calculate the density of the copper. Atomic mass of copper is given. Avogadro's number is given. Atomic radius of copper atom is 128 pm. Okay, same formula. You put the same formula for question number 8. Same formula you put, and you will get the answer 8.9. The answer is 8.9. Choice B is the correct answer. Okay, next, an element has atomic mass 93 gram mole inverse and density is this much, 11.5 gram cm minus 3. If the adds length of this unit cell is 300 pm, identify the type of the unit cell. What type of unit cell you have to taken. Okay, so same formula. Question number 9 is also using the same formula. Rho is equal to Z multiplied M by AQ by Avogadro's number. You put all these things, and you will Z for Z, you will get rho multiplied AQ NA divided by M, and the answer you will get, it is 2.01, which is approximately equal to 2. So if Z is 2, then it is for what? BCC, body centered cubic. Okay, so answer choice B is the correct answer. Okay students, have a good day.